Hello everyone, welcome back to Aapki Kaksha. So in this video I would be covering 10 important questions of class 12 that can come in NEET examination. So question number 1 in this says a point charge of 100 microcoulomb is situated at the origin. The magnitude of electric field at a location having position vector 3i cap plus 4j cap meter is. So we need to find the magnitude of electric field, and we know that electric field is given by E equals Ku r square. So in this case we are given with Q value, that is 100 microcoulomb, and K we know is 9 into 10 raised to power 9. Now what we need to find is the point charge is at origin and the position vector of electric field is at the location 3i cap plus 4j cap. Now we need to find magnitude of position vector. So it will be under root 3 square plus 4 square. 3 square plus 4 square is 25. So under root 25 gives us 5. So our vector is 5 meter here. So in this case what we need to do is we have the value for K, that is 9 into 10 raised to power 9. Then we have Q. Q is 100 microcoulomb. But you need to see the options as well. So in this we have K n values or n values. So let's see. We will convert this into K. So it will be 100 into 10 raised to power minus 6 over r square, that is 5 square, that will be 25. So we can solve this, we can cut 25 and 100, so we'll get 4. So this can be written as 36 into 10 raised to power 3. So 36 into 10 raised to power 3 can be written as 36 kilonewton over coulomb. So 80 minus 24 is 32, and 32 equals Q over 2. Now this 2 will come over here, so it will be 64 microcoulomb. So the Q charge is 64 microcoulomb, that is the third part. Now moving on to question number 4, we have is equivalent capacitance of the circuit shown in figure. The points A and B is. So we need to find the equivalent capacitance. So here what we will do is, there is one hint that says remove short circuited capacitor. So we will be removing the short circuit capacitors here and will be redrawing the circuit again. So starting from A, we will make C here. Then after it we have again C. Now again in the middle we have C here, capacitance, then again C, that ends at B. So we are removing the short circuited capacitor. So this one we removed, and these are the short circuited capacitors. So we need to remove them. Now we need to find the C equivalent. So C equivalent will be as you can see, we have 4 capacitance here. So here you can see that these two will be like this as they are in series. So 1 over C, 1 over C. Then in the end you can write 1 over 2C. So C equivalent is 1 over C equivalent because it is in series and then in parallel. So it will be 1 over C plus 1 over C plus 1 over 2C. So it will be 2C, and multiplying the first with 2 and the second with 2 again. So it will be 2 plus 2 plus 1. So it will be 5 over 2C. Now reciprocal of it will give us 2C over 5. Let's start with question number 5. So we need to find the value of current IE in the electrical network as shown in the figure S. So here you can see we need to apply Kirchhoff's current law again, and it says that summation I in equals summation I out. So in this case I in is the current which is going inside. It is 10 ampere. Then we have 3 ampere. Then we have I, that is 10 plus 3 plus I. So these are the 3 current that is going inside. Now outside one we have is 1 plus 2. Then we have 11. Then the last one is again 1 ampere, this one. So 1 ampere. So we have 13 plus I on the left hand side. And on the right hand side we have is 1 plus 2 plus 11 plus 1. So it gives us 13, 14, 15. So it will be 50. Now we need to bring 13 to the right hand side. So it will be 15. Take away 30. So it will be 2 ampere. So the right option here is first part. So this is for question number 5. Question number 6 says a frustum of cone having radii 5 meter and 2 meter of its plane surfaces is kept in a uniform electric field, that is 5 Newton over Coulomb, perpendicular to the plane faces. So you can see that plane faces are these and they are perpendicular to the plane faces. Now the magnitude of electric flux through the curved surface area of the frustum is. So now in this case we know that flux equals E vector dot A vector, that is the area covered. So net flux here is actually 0. Why 0? Because if I take phi of curved surface, phi of curved surface plus phi of plane surface here equals 0. Now in this case phi curved is not known to us. What is known to us is phi plane faces. So here we have, here it says E dot A. So that means we have circle here. So for the first one it will be minus 5 pi r square. So radius for this is 5. So it will be pi r square, that will be pi 5 square. Now removing, or we will be adding here because minus plus is minus, sorry, minus is plus. So it will be 5 pi r square, that will be pi 2 square equals 0. So phi curved will be 5 pi, 5 square is 25, 25 minus 4. So it will be 16. So 21 into 5 is 100, 5 pi Newton meter square over Coulomb. So this will be phi curved for the electric flux through frustum. So the right option is second part. Now moving on to question number 7. So it says a charged particle of mass m and charge q is projected towards a fixed charge particle of charge 3q along the line joining them with a speed v from a very large distance. The minimum separation attained between the particle is. So what we need to do is, this is actually related to conservation of energy, because it says that a charged particle of mass and q is projected towards a fixed charge particle along the line joining them. We need to find the minimum separation between the particles. So we know that we have energy as half mv square, and on the other hand we have E as, or the force as, K into Q1 into Q2. So here we have Q and we have 3Q over R. So now in this case what we need to find is, we need to find the minimum separation. So the minimum separation is R. So rearranging the terms, we get R as, R goes up and these will go here. So it will be 6, 3 into 2 is 6. So we have K Q square over mv square. So we have 6 kq square over mv square. So the right option is first part. Now moving on to question number 8. It says the capacitance of each capacitor as shown in the circuit is C. The effective capacitance of the circuit between terminal A and B is. So we need to find the C equivalent here. So now you can see they are in parallel. So in the first one we have C, in the second one we have C, C, then 4 C's, then infinite C's at the end. So if n number of identical capacitance are there in series, then net capacitance is C over n. So this is known to us that whenever we have a net capacitance and if they are in series, then we can write it as C over n. Now in this case the C net will be C plus, when we solve this, what we will get is 1 over C plus 1 over C equals 1 over C equivalent for the second one I am doing for this one. So it will be 2 over C, and if I take reciprocal of this, we will get C over 2, and if we have 4, then it will be C over 4, and if we go on, it will be C over 8 and go on. It will be like infinite times. So here C net will be equivalent to C. This is actually one of the formula of sequences, that is A 1 minus n. So A is the first term here. First term is C. 1 minus n means 1 minus, sorry, it is D actually. D is actually the difference between first two. So C over 2 and C gives us half. So it will be C over, taking LCM at denominator, we get 2 minus 1 over 2. So it can be written as 2C. So the right option for question number 8 is D part. Now moving on to question number 9. Here we are given with effective resistance of the infinite resistance ladder circuit between terminal A and B. So here I will take effective resistance between A and B as X. So I will redraw the figure as A and B. Here we have 2 ohm and in between we have 4 ohm. Now as we have infinite resistance ladder, so I will end it here and will mark a resistance here and mark it as A dash and B dash. Now suppose the effective resistance for this is X. Now if this is X, you can see the the parallel resistance we have are double, like 4, 8 and 16. So if this is x, then this must be 2x. So let us take the effective resistance between A dash and B dash is 2x, and between A and B it is x. We don't know what the effective resistance of A and B is. So in this case, what we need to do is, the first one we have is 2 ohm plus 4 ohm plus 2x. They are in parallel. So it can be written as 4 into 2x over 4 plus 2x equals x. Why? Because the effective resistance between A and B is x. The effective resistance between A and B. So it equals x. Now 2 ohm plus, we have 4 plus 2x at the bottom, so we'll be taking LCM of it. So taking LCM, or we can do one another method, that is we can take 2 ohm to the right hand side. So it will be 4 into 2x over 4 plus 2x into x minus 2. Now what we will do is, on the left hand side we have 8x, on the right hand side we will multiply these two. So we will get 4x, first term with first term with second, so plus 2x square. Then second term minus 2 with 4, so it will be minus 8. Then minus 2 with 2x, so it will be minus 4x. Minus 4x gets cancelled out. So we are left with 2x square minus 8x minus 8 equals 0. So now in this case, we will take common 2. So it will become x square minus 4x minus 4 equals 0. So therefore the equation is x square minus 4x minus 4 equal 0. So this is the equation we have. Now we can use quadratic formula to solve this. So using quadratic formula we get x equal minus b, minus minus is 4, plus minus under root b square minus 4ac. So it will be 16 minus 16. So it will be positive 32 over 2. So we get 4 plus minus under root 32. Now 32 can be written as 4 under root 2 over 2. So we get, dividing 4 and 4 with 2, so it will be 2. 2 plus minus under root 2. And we know that it won't be in negative, so therefore we will take only the positive term, that is 2 plus 2 under root ohm. So the right option for this is the first. Now moving on to question number 10, it says, on closing the switch S in the circuit as shown in the figure, the reading of the galvanometer G is. So here we are given with balanced Wheatstone bridge. So the circuit is a balanced Wheatstone bridge, and therefore the current through the galvanometer will always be 0. So in this case, the right option will be 3. That is, it remains safe because it is of the type Wheatstone bridge. So that's all for today's class. We'll come up with more questions. So stay tuned with us and please subscribe to my channel. Thank you for watching this.